Today we will be learning about Columbic Attraction. I hope you enjoy. Now what exactly is Columbic Attraction? Columbic attraction is the measure of attraction between the negatively charged particles in the atom, which are electrons, and the positively charged protons in the nucleus. These work almost in the same way as magnetism. Opposites attract, and thus electrons with a negative charge are attracted towards the protons with a positive charge. And we can increase or decrease Columbic attraction using either the distance between two particles. So for example, if we have a nucleus and a bunch of electrons around it, the electrons that are farther away will have less Columbic attraction, but the electrons that are closer will have much more Columbic attraction. This is because of the shielding effect. When there are more shells in between an electron, the electrons are gonna shield themselves away, more like repulse themselves away, because they are the same charge, and thus they'll repulse each other. We can also increase and decrease Columbic attraction using the number of protons. You see, when you increase the number of protons, the Columbic attraction increases, and when we decrease the number of protons, the Columbic attraction decreases. And this Columbic attraction can either make the electrons go closer or farther away from the nucleus. Trends in the periodic table. Columbic attraction is actually organized in the periodic table. It's actually organized in a way where we can estimate the Columbic attraction relative to other elements in the periodic table. So, for example, if we have the periodic table of elements right here, and we have it all of the elements, we can relatively figure out how much Columbic attraction they have depending on where they are. So, as we go down in the periodic table, we'll see that the Columbic attraction gets much lesser, and thus the atomic size gets larger since the electrons are farther away. So these arrows show atomic size, but when we convert it into Columbic attraction, these arrows actually show the opposite. So when you're trying to figure out how much Columbic attraction oxygen has versus nitrogen, we'll say oxygen has more Columbic attraction even though it has less atomic radius. So the best way to figure out if something has more Columbic attraction is to see the radius of the atom. If the atom is smaller than the other atom, then you can probably say that it has more Columbic attraction. Of course, there are a few, very few exceptions to this rule, but they are very minute. Goodbye, and I hope you like and subscribe.